A Class 1 appliance is an earthed appliance. Open the plug to determine if the appliance has 3 wires. A Class 2 appliance has no earth wire. Again, open the plug to determine that there are only 2 wires. A double insulated appliance is marked with this symbol and must be tested in the same way as a Class 2 appliance.
The earth continuity test is used to verify that there is a good electrical connection between any exposed metal parts and the protective earth pin in the mains plug of a Class 1 appliance. As we can see, the appliance is plugged into the PAT and the test probe is connected to exposed metal parts. Current is then passed from the PAT tester through the protective earth conductor of the mains cord to the enclosure. It then flows back to the PAT tester via the protective earth conductor. The PAT will then display the resistance of the protective earth path. Insulation testing is carried out by plugging the tested appliance into the PAT and applying a test voltage of 500 volts DC to both the live and neutral terminals of the mains plug. If the insulation is in good condition, a high insulation resistance reading is obtained, typically in the order of hundreds of megaohms. If there is a breakdown in insulation between live parts and protective earth, a current will flow across the insulation and back to the PAT via the protective earth conductor. The measured insulation resistance is greatly reduced, indicative of an insulation fault. When testing insulation on a Class 2 appliance, the test probe is connected to any exposed metal parts. If the exposed metal parts are insulated from live parts, a high insulation resistance measurement is obtained. If there is a breakdown in insulation between live parts and any exposed metal parts, a current will flow across the insulation and back to the PAT via the test probe. The measured insulation resistance is greatly reduced, indicative of an insulation fault. To measure a protective conductor current, the appliance is plugged into the PAT. When the appliance is energized, current will flow from the main supply to the appliance in the live conductor, indicated via the brown arrow, and then return to the supply via the neutral conductor. If there is good insulation between live parts and protective earth, the live and neutral currents are equal, i.e., all of the current entering the appliance in the live conductor returns to the supply in the neutral. If there is a fault with the insulation, some of the current flowing in the live conductor will return to the supply via the protective earth. The PAT will detect this imbalance in the live and neutral currents and display the result. The touch current test is carried out by connecting the PAT to the appliance and the test probe to any exposed metal parts. If there is fault with the insulation, some of the current flowing in the live conductor will return to the supply via the test probe. The PAT will measure any touch current returning via the probe and display the result. The flash or dielectric strength test is carried out by applying a high voltage, typically 1500 volts AC, to both the live conductors of the appliance. If there is any breakdown in the insulation, the PAT will measure the current flowing through the insulation to protective earth. A test probe is required when testing a Class 2 appliance. The probe is applied to any exposed metal parts. If there is any breakdown in the insulation, the PAT will measure the current returning via the test probe. An RCD is tested by connecting it to the main supply and using the tester to generate a fault current equal to the rated current of the RCD. As the animation shows, the fault current will trip the RCD and the tester measures the trip time.
Fuses are used in circuits to prevent excessive currents flowing under fault conditions and causing a fire. The primary purpose of the fuse is to protect the mains cable and prevent it melting and/or catching fire under fault conditions. The type of fuse used depends on the power of the appliance. To spot the difference between the fuses, each is colour-coded for easy identification. A 3 amp fuse is red, a 5 amp is black, and a 13 amp is brown. Fuses in moulded mains plugs. As these plugs are moulded to the cable, the fuse in these can be fixed by the manufacturer. They know what the maximum current is that the cable can carry, and the fuse is selected to protect the cable and blow if the current exceeds the capacity of the cable. The value of the fuse that is fitted is marked on the outside. All you have to do is to check that the fuse fitted is the same or lower than that marked on the plug. Here the moulded plug has to be fitted with a 3 amp fuse, as this is what is moulded on the plug. Fuses in rewirable mains plugs. These are plugs which the user can wire. Rewirable plugs have 13 amps marked, as they can handle a maximum of 13 amps. Many people assume that this means a 13 amp fuse should be used in this appliance, but this is not the case. The person inspecting the appliance has to work out the value of the correct fuse. If a plug is fitted with a 3 amp or 5 amp fuse, then there is no need to change it. There is very little risk of fire. If a plug is fitted with a 13 amp fuse, then you need to find out what the power consumption of the appliance is. This is usually indicated in watts on the rating plate. If the power is greater than 700 watts, then leave the 13 amp fuse in place. If the power is less than 700 watts, then change the fuse to a 3 amp one. This is shown on the following diagram. Never change a fuse on a working appliance from a lower one to a higher one. We'll now look at some examples to establish the correct value of fuse to use. Example 1. Iron. An iron is fitted with a 13 amp fuse and the power consumption of the appliance is 1900 watts as seen here. This is greater than 700 watts. The 13 amp fuse is the correct fuse for the appliance. Example 2. Lamp. The advice on the rating plate of this lamp says that the maximum bulb that can be fitted is a 40 watt one. The plug, however, is fitted with a 13 amp fuse. As the power rating is less than 700 watts, we can quickly see that the fuse is too high and has to be changed to a 3 amp one. Example 3. Sandwich toaster. This sandwich toaster has a plug fitted with a 13 amp fuse and, according to its rating plate, has a power consumption of 700 watts. As this is right on the decision threshold, what should we do? In general, heating appliances are fitted with a 13 amp fuse and this can be left in place. Example 4. Drill. This drill has a power rating of 570 watts and is fitted with a 5 amp fuse. Remember, if the fuse fitted is 3 amp or 5 amp, do not change it. There's no need for any action with this. Fuse labels. Once a plug has been checked for the correct value of fuse, it's good practice to seal the plug. If on future inspection this seal is intact, then this is a good indication that no one has tampered with the wiring or changed the fuse. This will save considerable time during subsequent inspections. In summary, fuses protect cables and appliances from overheating and causing a fire. If a 3 amp or a 5 amp fuse is fitted, then these can be left in place. If a 13 amp fuse is fitted, then check the power rating of the appliance to see if this is correct.
PAT testing using a BAT PAT. This video module shows how the BAT PAT is used to carry out PAT testing. Testing a Class 1 appliance. Plug the appliance into the BAT PAT and clip the test feed to a suitable earth point. Make sure that the appliance is switched on. Press the Class 1 button and wait for the BAT-PAT to display the results of the earth continuity and insulation resistance tests. Testing a Class 1 plastic appliance. Plug the appliance into the BAT-PAT. On these appliances, there is no place to clip the earth lead onto, so leave this to one side. Make sure that the appliance is switched on. Press the Class 1 plastic button and wait for the BAT-PAT to display the results of the insulation resistance test. Testing a Class 2 appliance. Plug the appliance into the BAT-PAT. If there is any metal work, clip the test lead onto this. Press the Class 2 button and wait for the BAT-PAT to display the results of the insulation resistance test. Testing an IEC lead. Plug both ends of the IEC lead into the tester and press the power cord button. The BAT-PAT carries out the test and displays the results of the earth continuity, insulation resistance and polarity tests. The polarity test checks the lead is wired correctly. Testing a standard mains extension lead. Plug the mains extension lead into the BAT-PAT. Connect the short IEC lead to the socket of the mains extension back into the PAT tester as shown. Press the power cord button and wait for the BAT-PAT to display the results of the earth continuity, insulation resistance and polarity tests. Testing a long mains extension lead. Plug the mains extension lead into the BAT-PAT. Connect the short IEC lead to the socket of the mains extension back to the PAT tester as shown. Press the long lead button and then press the power cord button and wait for the BAT-PAT to display the results of the earth continuity, insulation resistance and polarity tests. Testing 110 volt appliances. Use the 110 volt adapter to plug a 110 volt appliance into the BAT-PAT. Using this adapter, you can carry out a test on a 110 volt appliance as shown here. Testing a Cloverleaf laptop power cord. Use the adapter shown to connect the Cloverleaf laptop power lead into the BAT-PAT mains socket and IEC socket. Press the power cord button to carry out a full test on this lead. In summary, the BAT-PAT is a simple to use yet versatile PAT tester. It can be used to test a wide variety of appliances.